Hi, everybody. How are you doing? Hopefully well. So today we are going to start talking about Chapter 11. Chapter 11 is about exponents and logarithms. So pretty much a review of stuff you've seen before. I know a lot of you had talked about logarithms, not feeling super confident about them. So we'll be reviewing those the next couple of weeks, and then we'll get into some early calculus ideas. So today we're just going to review exponent rules. So just quickly, if you want to have a sheet of paper out to jot them down, you can. I'm going to try to keep this short. So product property. We've used these a little bit before this year. It's just the idea that if you're multiplying two things with the same base, you're going to add the exponents. So this would just become x to the seventh. If I had something like, I don't know, 3x to the fifth times negative 4x to the eighth, right? I would just treat that they're all being multiplied together. So this is like having 3 times x to the fifth times negative 4 times x to the eighth. And then I could multiply these together, so negative 12. And then when I multiply these, the same base together, that would be x to the 13th. Okay, so multiplying things with the same base, add the exponents. Right, now, power of a product, I'm kind of combining this one with power of a power. So power of a power is just like if I had x to the fourth and then to the eighth power, that would be that I multiply the exponents together, because technically the eighth power on the x to the fourth would mean x to the fourth written out 8 times. And then I could add 4 8 times, which is the same as multiplying. So this is x to the 32nd. So that's power of a power. The power of a product is if I were multiplying. So let's say I had 3x to the fourth, y to the second, and that was all to the fourth. That's just the idea that I have to apply that fourth power to everything inside the parentheses. So I have to do 3 to the fourth times x to the fourth times y to the second to the fourth. Now, when I'm powering that 3, it's not that I multiply those, and sometimes people get confused about that because power, you multiply powers, but this is just 3 times 3 times 3 times 3. So that's just 81, and then it would be x to the 16th, y to the 8th. Okay. Our quotient property, remember, is if I had something like y to the 7th divided by y to the 3rd, the idea is that I would subtract the exponents, because if I were to write this all out, 1, 2, 3, 4, 5, 6, 7, all over y times y times y, I would get 3 pairs that cancel out and would leave me with y to the 4th. So rather than do that every single time, I can just subtract the powers. So if I had y to the 20th over y to the 4th, I could just say that's y to the 16th. Okay. And then this, how we had power of a product, we can also have power of a quotient. And that would just be that I apply, again, the power on the outside to everything inside. So if I had x to the second over y to the third, and that whole thing was to the, I don't know, third, I would have to do x to the second to the third, so x to the sixth, and then y to the third, or y to the ninth. All right, remember the zero power property, just anything to the 0 power is 1. Right, so if I had 2 to the 0, that's 1. If I have x to the 0, that's 1. Anything to the 0 power is 1. Where that comes from is if, let's say I had x to the 5th divided by x to the 5th. I know that equals 1 because anything divided by itself is 1. But if I were to use my quotient property and did x to the 5 minus 5, that equals, x to the 0. It equals x to the 0. And I also know that that's 1, so that means that must equal 1. All right, and then we will sometimes have negative exponents. With negative exponents, remember the idea is it basically becomes a reciprocal. Okay, so if I had 2 to the negative first, that becomes 1 over 2 to the positive first, or 2 to the first. If I had 1 over x to the negative second, Okay, I could think of this as 1 over x to the second, but then that's just x to the second, right? Because this is like having 1 times x to the second over 1. Okay, so the idea is if it's in the negative exponents in the top, I move it to the bottom and make it positive. If it's in the bottom, I move it to the top and make the exponent positive. Okay? All right, and then the last thing we're going to review is the idea of rational exponents. We talked about this a little bit last semester. It came up that rational exponents can be written as roots. So when this is to the 1/5 power, this is like saying this is the 5th root of 32. So what number times itself 5 times is 32? 2. Now, what if it was 32 to the 2/5 power? Okay, so we could rethink of this as 32 to the 1/5 power to the second, or we could think of it as 32 to the second to the 1/5 power. Either of those are equivalent. Okay, so look at that. Do you agree that when you do power to a power and multiply, it's 2/5 for the power, or here it's 2/5 for the power, either way. Okay, so then we could evaluate this one of two ways. So 1/5 power is the same as the 5th root of 32 to the second. So 5th root of 32 is 2, we just said, and 2 to the second is 4. So this is equal to 4. Or we could square the 32 and take the 5th root of whatever 32 squared is. Now, usually if we were doing this in class, I would give you guys a little power sheet and had all the powers, and I will put that, it is in Google Classroom, or I'll put that in Google Classroom for you if you want to have that to refer to. But just think, and I know I can't control this in any way, and I'm not testing you or quizzing you, so it doesn't really matter, but try to do these without just putting it into your calculator. Think about how would you do it if you just had a sheet that had all the powers on it. Okay. I would not have the 32 on your power sheet, right? So what's always going to be easiest when you're doing something like this, so if I gave you, let's say, 8 to the 4/3 power, is to think of this bottom number as always the root, and this top number is always the power, because I could rewrite this as 8 to the 1/3 power to the 4th. So that means the cube root of 8 to the 4th. So if in general you just think of it when you have a fraction, the top number is the power, the bottom number is the root, it really doesn't matter the order that you do it in, but it will be easiest if you first take the root and then take the power. Okay, so this would have been 2 to the 4th, which would be 16. All right, now I'm going to throw in there a negative exponent. So I could rethink of this now as 32 to the 1/5 to the second to the negative first. Okay, again, if I multiply those all out, it's negative 2/5, so it's equivalent. The order really doesn't matter. I could do the 2 here and then negative 1, or the negative 1 first, it doesn't matter. But like I said, I usually like to start with the root. And so this would be 2 squared and then to the negative first. So this would be 4 to the negative first. And this negative 1 power means take the reciprocal. So this would be 1/4. So in general, the bottom number is going to tell us the root to take. The top number is going to tell us the power. And if it's negative, that's going to tell us to take the reciprocal. Again, you could do that in any order. Right? I could take the reciprocal of 32 and say it's 1 over 32 and then do the square root and then, or do the 5th root and then square it. But no matter what, I'll get the 1/4. All right. And the last thing that's going to show up on your assignment is solving some basic equations that might have some rational powers. Right? So something like this, x to the 2/3 equals 16. So you could rewrite it with the roots and the powers if you want. So we could rewrite this as the cube root of x squared equals 16. And then I could go backwards from there. So I'm going to show it to you both ways. So if I wanted to undo the squared, I would take the square root of both sides. And then I would have the cube root of x equals 4. And then to undo the cube root, I would want to cube both sides. So that would be 64. So that would be one way to do it, kind of break it down into the root and the power and then do inverse operations. Or right here, what I could do is I could think, well, I want to end up with just x to the first power. So what could I do to this to turn it into just an first power for my exponent. And I know power to a power, I multiply. So I want to multiply this power 2/3 by something so that it's going to give me an exponent of 1 right here. Okay, so I would need to multiply, or take it rather, to the reciprocal power, because 2/3 times 3/2 is 1. If I do that to the left, I have to do that to the right. Okay, so then I have 16 to the 3/2 power. Well, 16 to the 3/2 power means I'm going to do the square root of 16, and then I'm going to cube it, right? It just means the square root of 16 cubed, which is 64. Okay, it's not necessary to like write this out. If you can think of that in your head, like, okay, I'm going to take the square root of 16, then I'm going to cube it, and I'm going to get 64. You can definitely go right from here to here. These are things that can be done in your head, or if you have a little power sheet, that might be helpful too. Okay, so that's just a quick recap of exponents, rational exponents, the properties, and then rational exponents. Your assignment is, it might look lengthy. It's an 11-1 practice worksheet, but they're quick, right? They're quick. You're like, oh, I add the exponents, I multiply the exponents, or you're doing one of these with the rational exponents. So it should not take you too long, even though you might look at it and say, like, oh my gosh, this is so long. Also, the answers are at the bottom, and I'd check for typos, but there could be one. So just let me know if you see a typo, and then I'll put it in the instructions for people so that they know that they did it right and I just screwed something up. Okay, I hope you're all doing well. Take care. All right, now I got to get out of here. That's the most fun part. All right, there we go. All right, bye guys.